Hello and welcome to our Source Talks webinar. For those attending who are not familiar with Source Group International and our brands, we are international recruitment specialists specializing in tech and life science recruitment. At SGI, we're on a mission to achieve the highest level of customer service, driving sustainable improvement and investing in our people. Source Talks community is a global community bringing together experts and leading professionals to discuss the challenges and changes they face across their organizations. Through our meetups and media series, we're pulling back the curtain to technology and talent attraction and building a powerful community of people on the same journey, looking to achieve similar objectives. Without further ado, I'd like to welcome my colleague Francis to intro our talk today. Thank you.
Thanks, Imogen, much appreciated. So again, apologies for the slight technical issues, but we're going to get moving as we speak. So as Imogen alluded to, we're putting together a series of webinars to give back to the Scala community to showcase, what leaders are doing within the field and solving everyday problems that apply to you guys out there that are using Scala in your day-to-day work. Little bit of housekeeping. I'm going to hand over to Łukasz Gajowy from Scalac shortly. He's going to kick off and discuss monitoring Scala applications using Mesmer and OpenTelemetry. If you do have questions, we welcome them, absolutely. But what we would ask is if you could send them in the chat, and then I can do a Q&A at the end, just so Łukasz it doesn't interrupt his flow. But without further ado, Łukasz.
Hello, nice to be here. Can you hear me?
Perfect.
Yes, I can.
Perfect. All good.
Oh, great. So my name is Łukasz, and let me just share my screen. It should be fine. Do you see my slides?
Yeah, looks great.
Yeah, we do. Perfect.
Great. Let me just unpin this thing. Okay, so as I said, my name is Łukasz Gajowy, and as I was introduced, I'm a Scala developer at a company called Scalac. This is a Polish company. Actually, it's international. We have co-workers from all around the globe, and we are a Scala company. We have very talented developers that do Scala functional programming, and quite recently we do a little bit of OpenTelemetry. So this is why today I'm here to tell you a little bit about monitoring Scala applications with Mesmer, which is our tool, and our open source product, and OpenTelemetry, which is the thing without which Mesmer couldn't even exist. So this presentation will be divided into 3 parts. The first part is going to be about OpenTelemetry in general. So if you're completely new to this area, I hope that this will be helpful. Then I'm going to jump a little bit into some Java-specific bits of OpenTelemetry. So things that allow you to do automatical instrumentation and extending the OpenTelemetry agent. It's really interesting, and that actually helped us to create Mesmer. So by the time you hear about the OpenTelemetry extension, you will probably have a light bulb in your head with an idea what Mesmer actually could be. So without further ado, let's do this. I usually start my presentations with some specific examples, but this time this example that I'm going to present to you is going to be a little bit general. So say you have a system that has a front-end application that is written in JavaScript. Then you have some services, 2 instances of a service written in Java, but quite recently you decided with your team to migrate to Scala, at least to some degree. The whole team decided to compare whether it's best to stick with Java or to migrate to Scala. And since your application, let's say, requires some machine learning, some data processing, you have 2 instances of services written in Python. So that's a quite a complex application. It has 4 languages involved right now. And to have some, and at some point, you started asking questions. First of all, because you get, more users and whatnot, so the questions started to be more important. The answers to those questions started to be more important. So the first question is the product that you've just built always available, or do you have any downtime? Well, pretty important question, especially if you want to earn some money. Then, how many HTTP requests do my services can handle? Is the Java application better, or is the Scala application that we've just built to use something more modern? Is it performing better or worse? The third thing is what is the case with the SQL queries? While you were migrating, maybe you improved something. So maybe it's also good to have the numbers that will tell you that your queries are actually faster in the new service. What are the steps the system takes to fulfill a request? So that's also an important information. For example, if you send a request via the front-end application to the Java service, does it always then go to the Python service to calculate, to do some data processing? Or maybe for some requests, this is not necessary. And last but not least, and actually this is super important when you have multiple applications in your system, do you have a place where you can see logs in one place, right? So when you're debugging, so that you don't have to enter every console window of every service separately. You just want to have this aggregated. And the answers to those questions can be covered with something that is called telemetry data. So to get the HTTP request throughput, you will probably use some metrics API that will collect such a metric, the request throughput or rate, and you will probably store it in some metric-specific database. When it comes to SQL query execution time, this is quite similar. You will probably also use metrics for that. When it comes to request execution path, this is something that is called a trace. So tracing does exactly that. This is, if you've seen any stack trace, you probably get the idea. But this is actually one of the telemetry signals that can be nicely presented in some nice UIs, so that you could debug even faster. And for logs in one place, that's something that requires log collection platform, such as, I don't know, Logstash. So basically what you want to do is you want to take some data, some telemetry data, and send it over to some databases, some platforms specific to concrete signals. By saying signal, by the way, I'm going to refer to metrics, tracing, and logs at the same time. So this is what I call telemetry signals. So you're sending the data over, and that can, and remember that I told you that you have multiple languages, you have some data to send. So there's a series of problems that you will probably need to solve. The first problem being, you have per signal type APIs and SDKs. So if you are sending metrics and metrics only, that's probably not a problem. But in our case, we are sending metrics, tracing, and logs. So you already need 3 APIs to learn. And when it comes to learning new APIs, you have per language APIs and SDKs, and they tend to be different than from each other. So when you have a JavaScript API that is connecting to Prometheus, that's probably a little bit different than the one written in Java. The third thing is that when you use a particular API, then you will probably need to stick with it for a long and it's going to be a little bit hard to run away from it. So vendor lock-in. And again, example, when you're using Prometheus and you write some code to collect metrics from your applications, and say you have a lot of metrics, a lot of Prometheus code, migrating from that is not going to be a trivial task. Same goes for configuration when it comes to multiple APIs. You configure your APIs for tracing differently than APIs for metrics, than APIs for logging. Basically, every library has different default values that are not standard, and different ways that are also not standard. Those are the problems that are on this side, right? In your services, in your microservice, or whatever that is. You have those five problems, but when it comes to sending the data to the platforms that actually store and present the telemetry data, there's another batch of problems, such as whether you should send the data directly from every application, send it over to the platforms that collect particular signals, or whether you should send the data indirectly. Sending directly might be okay when the load of data is not so big, but when you have 3 types of signals and multiple applications, multiple instances of applications, that's probably a significant load of data that's going to be sent over your internal network. So you probably need a middleman that's going to, I don't know, batch the telemetry data, so send them in small batches periodically. Maybe you can scale that middleman, so there's not only one instance that does the batching. And you probably could do some additional transformations, so merging the metrics or adding some attributes to them and whatnot. And even after those problems that I just shown you, there's probably a lot more that I skipped. So as you can see, that problem is not so just adding the telemetry to your application may not be so trivial, especially if you need all of the 3 signals. So there's the solution, or at least maybe not a full solution, but a mitigation. This is how I like to think about it. And it's called OpenTelemetry. OpenTelemetry mitigates the problems by giving you a standard specification. So you have a whole repository full of documents that tell you how a particular API should be written, what configuration should be provided, what defaults should be added, how do you export the data. It also provides you with the description on how the OpenTelemetry protocol works and whatnot. But the key word here is that it is standard. So everything starts here from the specification. And every language, because you still have multiple languages, has a standard API and SDK. What it means that the APIs are still written in multiple languages, but they are very similar because of the specification. The configuration is standard because of the specification. The exporters, which are the elements that are sending the telemetry data across the network, are also standard and can use standard protocols. And there's the middleman that I mentioned before when it comes to indirect communication. So whenever you need to do indirect communication, you can use something that is called the collector, which can be easily hosted by Docker and scaled and configured according to your needs. And since the telemetry backends are already there, and by saying telemetry backends, I mean, for example, Prometheus, Jaeger for tracing, or tools for logs, then the only thing that is needed to communicate OpenTelemetry pieces with the telemetry backends is translating the protocol that you used to transfer the telemetry signals to something that the telemetry platforms, telemetry backends understand. So this is what the collector and exporters do. So this is how it typically looks like in your application. Every time you add the signals manually, and that's also an important word that's going to be compared with the automatical instrumentation later. But every time you want to add the code manually, you import the API, the SDK, write the code that is needed for collecting your telemetry signals. And once you're done with that, you add the exporter that is able to send the data either over OpenTelemetry protocol, which would be the indirect way, and sending it over to the collector, or you could send the data directly. And this is not depicted on the diagram, but I figured why not say tell about this. So from the exporter, you can also go go straight forward to the particular platforms, and the translation is going to be done. Translation of the API is going to be done directly to the API of the particular tool. So two ways are addressed. Also, vendor lock-in is addressed in the way that, since this is a standard protocol, as long as you have the way of translating the standard protocol to a platform-specific protocol, you can use different platforms for metrics. I don't know, maybe some of the metrics should be stored in Prometheus, but for some others, you would like to have some additional, I don't know, smart things that the commercial metrics platform do nowadays, or whatnot. So this is how this looks like, but I didn't show you the code of how metrics, in this case, metrics can be collected, but it's pretty similar for other signals as well. So the only thing you need to do to collect a metric code-wise is you need to set up the global OpenTelemetry, which is a global way in your application to get something called meter provider, and meter provider gives you a builder for particular instruments. In this case, we want to count how many times we used a particular feature. So we are going to use a counter, give it a description, and build it. And and after we've built it, we can use it in any method of our choice. So we have a fancy feature, and we count its usages, but since we want to have more specific data, we add an attribute, which is a label in the Prometheus nomenclature, and we are giving the organization name label here, so that we could distinguish between different organizations, which one used the feature more often. And to actually run that, I already told you that you import some dependencies. So API, SDK. I also import the SDK extension for automatic configuration, so that I get some standard and well-designed default values, and do not need to worry about adding all the configuration parameters during startup. And of course, I need to send the data somewhere. So I need Prometheus, which is going to collect metrics. And I told you before, showed you before the diagram, we need the collector. So I can start it as easy as Prometheus using Docker Compose. And when I when I start my example application and wait a little bit, I will get the metrics presented in Prometheus dashboard. So that's it. It's that easy to collect metrics using OpenTelemetry. And I don't think there's enough time to show you how it looks like when it comes to tracing, but it's also easy. You add the code in a similar fashion. So you can instrument those two signals pretty easily and avoid the problems that you would have when you would be using multiple non-standard APIs. So that's really helpful. So you see that it mitigates a little bit of the problems that are there on the table, and you just write the code once and send the data anywhere. This is something that I like to think about OpenTelemetry in this way, because it actually is this way. You don't really need to change much when you're changing the tool. For example, change the metrics platform or whatnot. But there's a big question: do I have to write the code manually? Do I have to instrument the metrics, the traces, and the logs manually? Well, of course not, because OpenTelemetry has two instrumentation modes provided, at least for the Java API and SDK. I know that there is similar mechanism for Python, and this is called automatical instrumentation. And automatical instrumentation requires you only to configure your application to run with a, let's say, sidecar that is called an OpenTelemetry Java agent. Well, it's not really a sidecar. It's a Java agent, and Java agents are part of the Java language. This is a feature of a Java language. You can add a Java agent to run some code before your application starts. So this is what is used by OpenTelemetry. And what OpenTelemetry does using Java agents is that it detects what libraries does your application use, and then it manipulates the library code so that the metrics code and the tracing code is added to those libraries. So by the time your application is started, you get metrics and traces for free, basically. The only thing that you needed to do is adding the OpenTelemetry Java agent. And this is, as you may imagine, pretty useful, because some of the metrics are pretty how to say this, pretty common. So, for example, you have HTTP libraries. It's not something that you would like to instrument manually. This is something that some people could do for you. So the library is public, so why not manipulate the bytecode with the OpenTelemetry Java agent and have the metrics for free? So that's a nice feature. And when you start your example application with the Java agent, you get a bunch of instrumentations being loaded. So the bytecode manipulations are running when you see those logs. And after this is done, and you wait a little bit to collect metrics, you get traces and metrics for free, as I said. So in this case, I'm showing you a trace. The OpenTelemetry agent detected that there's akka HTTP library on the class path of your application. So it modified the bytecode so that there's so that the traces are collected. And it also detected that there's JDBC driver being used, so it also added trace for JDBC calls. And you can see quite a lot of useful information, such as invocation time, how long each call took and whatnot. And when it comes to metrics, this is working similarly. So some things such as process runtime, JVM memory usage were also instrumented with the metrics collection code, so that you could see how many memory is used over time. And the only thing you needed to do is, again, you just needed to add the OpenTelemetry agent. And this is all nice, but there's a question that I would ask at that time. What if the OpenTelemetry maintainers didn't instrument a library that I wish to have metrics taken from? Because they have, I imagine, pretty limited time, so they simply probably didn't cover as many libraries as we wanted, although there's lots of coverage right now. And yeah, so what do we do? Well, they were smart, and they provided us with the mechanism of extending the OpenTelemetry agent. And what it means, it means that you can override some instrumentations, such as, I don't know, you had the Akka HTTP instrumentation for traces. Maybe you want to change that. Maybe you want to modify the attributes attached to a trace or whatnot. You can do it via extensions. But for me and for Mesmer, the most important and the most interesting thing that I would like to present to you is that you can write your own library instrumentations. So even if your library is internal in your company, never published anywhere, you can write an instrumentation that would be attached to the OpenTelemetry agent in your company, and you will provide metrics this way. To do that, you need to do basically two things. You need to have a separate project that has the instrumentation module implemented. The instrumentation module describes the set of bytecode modifications that you would like to apply every time a particular your library is detected. And we need to give it a name, not a fancy name, but my instrumentation name seems pretty enough for this example. And type instrumentations method is the place where you add the list of bytecode modifications. I'm not going to go deeper here because this is all byte body details, not OpenTelemetry details, but that's the place where you attach that, and you need to make it detectable because this is a service provider interface. So this is why there's this annotation. And after you do that and build your extension to a jar, then you can add it to OpenTelemetry agent that is still there in the parameters, but you add it through another parameter called OpenTelemetry Java Agent Extensions. You can add even multiple extensions, but we are adding only one right now, and start your application. And after you do this, you can see that my instrumentation name was added to the list of the instrumentations that were loaded at the very beginning when the Java agent started. So if you had any code that instrumented metrics for your library or traces, then you're all set, and it should be collected by your extension. And that's what Mesmer does. That's exactly what Mesmer does. So Mesmer is an open source project made by Scalac. We provide Scala libraries with OpenTelemetry agent extensions, similarly as I showed you before. And we're currently focusing on metrics. So basically, it's a funny story. Maybe I will share it. It's all started because a client wanted to have OpenTelemetry metrics. Exactly the case that I just described. He came to our company and said, "You know what? I know there's automatical instrumentation, but how can we add instrumentations for my libraries?" And so we found the solution, and this is how Mesmer was created. So we right now, and since that client agreed for us to make it open source, there it is, and we are maintaining the tool. To run Mesmer, because this is what I'm going to show you on the next slides, you need to just add the OpenTelemetry agent and add the OpenTelemetry Java agent extensions parameter during startup, and you're all set. You will get not only OpenTelemetry metrics, but you will get also the metrics from Mesmer. What metrics are those? We currently are focusing on Akka and Zio. Zio is the fresh, nice Scala library, and Akka is the old, very stable, very commonly used library. Well, not only library, framework. And we have a whole set of new metrics for Akka. For example, Akka metrics such as, I don't know, created, terminated actors are collected, a lot more. You can see them in the supported metrics link over here. But there's also cluster persistence and streaming metrics. So all the things that we found useful to collect in Akka are there. When it comes to Zio, we are not providing any metrics that Zio doesn't provide. We are simply forwarding them to OpenTelemetry, so that whenever you use Zio and you already use its existing metrics API, because Zio has one, what we do is that we wrap the Zio API in our instrumentations so that you don't need to write any configuration code in your application to forward that to OpenTelemetry. And this is an example of Akka persistent event average time. This is something that we have in our Grafana dashboards. You can see various average times here. And this is an example of a Zio metric that is available when you turn on such metrics in Zio. So it's an example of JVM threads state, whether it's blocked, I don't know, runnable, terminated, and whatnot. So, but that's not on. There's also a whole lot of other metrics that are forwarded from Zio. It's not even the full list. I encourage you to see it yourself, how it works. And yeah, so we have some plans, some bigger plans to this project. It's still in an early phase, but we think that making it an OpenTelemetry extension is a great idea. So we're going to, extend it more and more so that it's more and more useful. But first, we're going to simplify our code base. There's lots of experiments that we had along the way and that need to be cleaned up. Then we are going to focus more on Zio, since this is something that we believe needs more focus. And at the same time, we plan to add instrumentations for more libraries. Maybe FS2, maybe CATS effect. Who knows? And we, as I mentioned, we are focusing currently only on metrics. but tracing is the big topic that personally I would like to investigate really much because it's super interesting. So expect some movement in this area in the future as well. So if you want to see the project in action, go to the links that I'm presenting you over here. This is our repository. Again, not only you can use it, but you can contribute to the project. It's open source. We are very fond of people that already contributed some things. And that's the page of the project where the documentation is. And I think that's it. I'm ready to take some questions from you, and thank you for listening to my talk.
Thanks, Luke. So we have a question already. What are the resource CPU/memory requirements of the collector, and also do you need to add any agent in your class path to emit any telemetry metrics?
Could you repeat the second part?
Yeah. Do you need to add any agent in your class path to emit the telemetry metrics?
To omit the telemetry metrics?
I think this one also, when I asked the question, I think you answered it later on. There was a slide where you talked about using the Java agent. I think this is what it refers to. So I guess the second one is answered, but it'd be cool to know, because you showed this this YAML file with the service definitions in there, and one of them was the collector. So I'd be interested to know what's the CPU and memory usage of this. Obviously, it depends on your usage, but yeah, I'd be keen to know.
Yeah, it highly depends on your usage, probably. I don't know the exact numbers, but I don't really know the answer for these questions, but what I can tell you is that you can configure the collector in multiple ways so that you can, to some degree, control the memory footprint, I guess. But sorry, I didn't really focus much on the collector while working on OpenTelemetry.
Thanks. Any more?
I guess I'm going to ask if people are shy. How is Mesmer different to Common, for example?
So as far as I know, because I've seen Common, I think it's a great tool to start with, and but it uses its own set of instruments. It's not like it uses OpenTelemetry directly. And what we are trying to do is that we don't have our custom API for metrics, traces, and logs. We are using OpenTelemetry solely. So that's the greater difference. I know that Common also can be used with OpenTelemetry, I think, at least to some degree. I know that there was some development in that area. But what it does is that the data collected by Common is then translated to OpenTelemetry on the edge. So it's not like in our case. And I know that Common has a custom agent, whereas we have the OpenTelemetry agent. So it's also that we don't need to add two different agents, I guess. But I'm not sure about that. I didn't really use Common much.
Okay, thanks.
I have a question.
Go on.
What are the plans for the future? I mean, do you have a plan or a timeline with the future supported the future supported libraries and frameworks?
So I think the most the thing that we're going to focus right now is ZEO, and since adding new metrics actually requires you to get to know the library really well, so that's probably will take us some time, and we don't really have any pretty written in stone plans for the different libraries, but I would really like to have some streaming libraries such as FS2 covered, or maybe for balance, that's probably a bad word, but CATS effect would also be nice to instrument. I don't know, or at least investigated by on our side what metrics can be provided. But to be honest, we're quite an open community. So if you think that you know a library that should be instrumented first, we can reorganize our plans and maybe focus on that.
Nothing particular in mind, but thanks for answering.
Thanks.
Lucas, can you elaborate on the Acometrics further?
So yeah, so basically 4 areas, as I described, we were focusing on the biggest focus was on the actor and the persistence metrics. For the persistence, for the actor we are counting, for example, number of messages. Or actually, you know what? I will open the link. It's going to be easier for me to explain you that. I should have a browser somewhere over here. It's here. Oh, sorry. Oh, it broke. Okay, never mind, but there's a whole list of supported metrics under that link. And okay, maybe I will just open the repository and go manually. So that's the full list. We recently had some problems with Akka streaming metrics because we took a different approach when it comes to instrumenting those, and I must sadly I must say that this is broken currently, but the other parts such as core metrics, cluster metrics, and persistence metrics are there. Values types of metrics such as gauges, counters, and histograms, of course, because you can't only have counters, it doesn't really make sense. And so yeah, it's best to see that in action when you actually play with it, I think.
Excuse me, can I ask something?
Yeah, sure.
So I want to know that if we, for example, configure these libraries for the OpenTelemetry automatically, can we use, for example, both with the manual things? For example, if we choose automatic and then we wanted, for example, use or pass it implicitly into our application, so we could add something else to the entire log. Can we do that?
Oh yeah, so that's basically, I mean, OpenTelemetry is designed to support that. So whenever you have automatical instrumentation, that doesn't mean that you can have to resign from manual code, from adding code manually to your application. And since this is standard, right, so you will use the same API, and the same set of tools will be used to actually send the telemetry data over to the platforms that you use.
Thank you. So if no one have something to say, is there any kind of API that or something integration between, for example, if you wanted to aggregate data and sending through the Kafka and the other stuff, can we do that with the OpenTelemetry as well?
I don't know about Kafka. I mean, that's a good question. I mean, you typically transport. For sure, you can transport your data over HTTP or gRPC protocol, but when it comes to sending them as Kafka messages, I would need to check that up. Probably there is already some, at least a thread in the OpenTelemetry repository that discusses that, because that's actually something that probably should be desired from OpenTelemetry. But anyway, I don't know about any. Sorry, I don't know about any Kafka support right now. But I hope that you can find it.
No worries. Thank you.
I think that is it. Unless anyone else has any questions before we wrap up, wanted to let you know that we have another event coming up on the 7th where we've got the guys from Distage, and they're going to be discussing pragmatic, pure functional programming approaches to application design and testing with Distage. It will be at 6 o'clock again, and I assure you there will not be any technical difficulties next time. But thank you all for coming. It's been brilliant to have you, and we hope to see you again.